Yo, what's up? Ricky Sanders here. If you live for fast cars, greasy hands, and solving problems under the hood, welcome to your new favourite spot. I'm all about real fixes, no BS, and showing you how to keep your ride running like a champ. So go ahead, smash that like button, hit subscribe, and let's make some noise in the garage. Enough talk, let's get ready.
Potassium ignition is one of the most common problems that requires a comprehensive approach to solve. The average user observes it when the motor is turned off, when it continues to run for some time, being disconnected from the ignition. Such a problem is fraught with serious breakdowns later and needs to be addressed as soon as possible. In order to understand why this happens, it is necessary to understand its essence, which we will try to do. The nature of potassium ignition. In theory, there are two types of potassium ignition, and for a more correct understanding of the causes and consequences of the problem, it is necessary to consider both variants. One of them is specifically used in the powertrain to ignite the fuel-air mixture. The appearance of the second is characterized by a failure in the operation of the motor, so it is considered dangerous. That would secure the unit, it is necessary to correctly identify the first signs of the beginning of the harmful phenomenon. Detonation is the explosive combustion of a fuel-air mixture, which is necessarily accompanied by a shock wave. Whereas potassium ignition is normal combustion of the charge, characterized by early ignition. Potassium ignition and the detonation process are interrelated. Increased thermal stress on powertrain components is a consequence of detonation. This in turn leads to potassium ignition, characterized by early ignition, low power, and overheating of the engine. Potassium ignition is also dangerous in that the engine does not stop after the ignition is turned off. As a consequence, the unit can go to pieces and completely fail. Symptoms of the appearance of potassium ignition in high-mileage engines. Potassium ignition appears due to deposits on the walls of the combustion chamber. To eliminate this effect, it is enough to periodically clean the unit from the formed plaque. Another characteristic sign, by which you can determine the beginning of the symptom, is the inability of the unit to turn off after the key is removed from the ignition switch. The engine continues to run, the fuel-air mixture detonates and ignites, the tachometer records the engine running at idle speed, and pops and vibrations are heard in the area of the space under the hood. Insufficient cooling of the powertrain by the system, spark plug selection error, overheating of the intake valve or piston. Fuel. By using poor quality fuel, the user causes soot to build up on the valves, combustion chamber area and spark plugs. Octane number, not corresponding to the required, does not allow the gasoline to burn completely, hence the cause of deposits. As the engine runs, it heats up the deposits, heating them to temperatures hot enough to allow self-ignition. This is why the engine doesn't immediately stop after the ignition is turned off. Bad fuel clogs the power system, including the injectors, which interferes with the atomization process. Gasoline begins to flood the combustion chamber. Excess gasoline provokes overheating of the engine and individual parts, which further aggravates the situation. The problem of low-quality fuel can be solved by washing the gas tank, cleaning injectors, replacing filters and supplying fuel hoses. Gas distribution mechanism. Increased advance angle can be the cause of potassium ignition. As a rule, such a problem occurs after incorrect replacement of the timing belt, mismatch of marks on the pinion, or wear of the crankshaft and camshaft gears leads to improper operation. As a result, there is not only overheating of the power plant, but also a severe drop in power, violation of correctness in operation. The appearance of detonation. Improperly adjusted ignition advance angle can entail valve burnout and expensive repair of the power unit. To eliminate the malfunction requires the intervention of specialists, since it is difficult to identify the problem. As an option, when replacing the belt and bearings, it is desirable to change and gears of all shafts. This will help to avoid negative consequences caused by potassium ignition in the future. Incorrectly selected plugs can be the reason that the engine does not immediately stall. Each plug has its own characteristics and properties of the insulating coating that dissipates heat. If the wrong plugs are installed, the unit is subject to severe overheating and is unable to stall in time after shutdown. Candles have their own potassium number and are divided into cold and hot candles. The appearance of the ceramic insulating coating tells which type the candle belongs to. A short insulator is cold, a long insulator is hot. Each power plant has its own design features in the structure of the cylinder head, its cooling. Hence, there are different requirements for the type of plugs. Putting the plugs that do not meet the norms, you can seriously harm the engine. The plugs, the most common cause of this negative phenomenon. Putting a hot plug, with a long insulator, there is an effect of preserving the heat from the burn fuel. That provokes the appearance of potassium ignition, from which the residual mixture is ignited, preventing the engine from stalling. Installing a cold candle, with a short insulator, creates the opposite effect, does not allow the motor to start normally, or stalls it at high speeds. To avoid problems with plugs, the user should refer to the technical documentation, or the engine passport. Factory thermal characteristics inherent in each unit will allow you to correctly select the right type of plugs, and buying them from trusted suppliers guarantees smooth operation and long service life. Intake valve, or piston overheating of these two parts also leads to the formation of potassium ignition. The causes of overheating can be several: low-octane gasoline, improper operation of the valve responsible for the exhaust, violation of the coating, or deformation of the piston, low engine power, prolonged operation of the unit at the limit of its capabilities, damage to the cooling system, etc. All factors that contribute to overheating of the powertrain are the reason for further progressive development of potassium ignition. Potassium ignition prevention and remedies. If you find on your engine signs characteristic of the occurrence of potassium ignition, you need to take action. Most likely it will be a major overhaul. Performing repairs, it is necessary to replace the parts that have used up their life in the process of operation. As a rule, these are oil caps and piston rings. The work itself requires a certain skill and knowledge, so it should be carried out by qualified specialists. Motor repair, the process is long, costly and labor-intensive. All components of the process depend on the degree of wear of parts and mechanisms. With its correct passage, such a dangerous phenomenon as potassium ignition will be eliminated. The power plant will begin to work quietly, steadily, without extraneous noises and signs of detonation. To preventive measures to eliminate potassium ignition of the mixture can be attributed: selecting spark plugs, based on the power plant. Manufacturer's recommendations, with the correct potassium number, and the correct base length, timely and proper prevention and maintenance of the power plant cooling system. Constant maintenance of the cooling jacket capacity, keeping the cooling pipes clean, use of the correct brand of working fluid. Do not overheat the engine during operation. Monitor the correct temperature of the engine in case of overheating. Identify and eliminate the causes. Use quality fuel, with the right octane number, recommended by the manufacturer of the unit. Regularly check the correct setting of the ignition advance angle. If necessary, correct it. XMLPH. In conclusion, if your engine continues to run after turning off the ignition, it may be a case of potassium ignition, a phenomenon that can stem from various issues such as fuel quality, timing problems, faulty spark plugs, or even complications with the intake valves or pistons. Recognizing the symptoms early is crucial for effective diagnosis and prevention. Regular maintenance, including checking fuel quality and ensuring proper timing, can help mitigate these issues. If you experience this problem, it's essential to address it promptly to avoid potential damage to your engine. Thank you for watching, and we hope this information helps you keep your vehicle running smoothly.